All right, good afternoon to everybody who's joined so far, and thanks for joining our webinar. We're just going to give it another minute or so just to make sure everybody's here. And once around 2 o'clock rolls around, maybe a couple minutes after, we'll get started and let everyone who hasn't jumped on a chance to arrive. Let's give it another minute here. I see some people are coming in still, so stand by. All right, let's get started. Hello, everyone, and welcome. My name is Doug Iwachow, and I am a marketing communication specialist at Testo North America. We have a great session for you today, transforming thermography with Testo thermal imagers. To kick things off, let's go through a few logistical matters. Our session today will run roughly 1 hour, and we will have all attendees muted, but we will encourage you to submit questions in the questions panel to be answered at the end. We will be recording the session today, and we will send the recorded version of the webinar to you afterwards via email. As a reminder, all attendees of today's webinar will be entered to win a brand new Testo 835 HR IR thermometer with humidity. The winner will be selected at random and will be contacted via email after the webinar. Excuse me. Now I'll go through a brief introduction to Testo and our products and services. For over 60 years, Testo has stood for innovative measuring solutions. Testo helps over 650,000 customers worldwide save time and resources, protect the environment, ensure quality, meet regulatory expectations, and increase the value of their goods and services. Testo is a major supplier of monitoring instruments for markets as diverse as chemical, food service and production, pharmaceutical and biotechnology, as well as commercial and residential HVAC suppliers. Our speaker today is Aaron Longacre. Aaron is a product manager for instrumentation at Testo North America and is a level 1 certified thermographer. He has over 10 years of mechanical contracting experience, in addition to 10 years of pharmaceutical supply chain project management. Recently joining Testo, Aaron manages Testo's diverse instrumentation profile in HVAC, combustion, electrical, indoor air quality, food, pharmaceuticals, and of course, thermal imaging. Aaron is a graduate from Albright College with a Bachelor of Science in Business Marketing and a Master's in Business from the University of Phoenix. He currently resides in the Westchester, Pennsylvania area and enjoys camping outdoors, hiking, and various adventure sports, as well as spending time with his 2 children. And with that, I'm going to turn things over to Aaron.
Great, thank you, Doug, and hello, everyone. I believe everyone can hear me here. So we'll go ahead and jump right into our webinar. Let's get to the next screen. There we go. Okay, so what we're going to cover today is Doug already did a great job about Testo. We'll maybe cover a couple little bit more details. We're going to primarily be discussing our thermal imagers that are actually made in Germany. So a lot of the design, research, development, and the building actually takes place in Germany. A little brief introduction for those that may not be familiar with thermal imagers and how they work, just a little brief overview. And then the key fields of application that thermal imagers are generally used, and exactly kind of how a thermal imager with the different sets that you may be able to look through with Testo, as amongst as other options you have as well. We'll take a look at all the thermal imagers that Testo provides and the models and the applications for how they work. Some of the important features and kind of what the differentiator with Testo is, a lot of the great unique features that are developed in these imagers, and then some of the advantages with Testo, and then some time for some questions at the end. So again, who is Testo? Doug did a fantastic job covering the facts and figures. Amongst that, we have globally about 3,400 employees globally with 36 different subsidiaries, so not just North America, but Testo is a global company. Our growth has been tremendous, as you can see through the graph over the last how many years. For the past 60 plus years we've been going. A lot of the unique aspects with Testo is a lot of our profits, our annual investment, we take about 10% of what we make, and that is always invested back into the company. So with Testo stands, we are constantly always trying to push the envelope in a lot of the tools that we make. So not just thermal imagers, but also digital manifolds, combustion analyzers, emission analyzers, data loggers, and indoor air quality instruments, because we really cover the whole gamut when it comes to anything, whether it's residential, commercial, or industrial. We cover it all. Again, 200 developers are located in the Lenzkirch, TSA areas in Germany, and also Berlin sites. And a lot of our focus is that high-tech sensors, apps, and cloud solutions. Again, we're broken up into 3 different areas where it's instrumentation, solutions, and services. So whether we build it and make it, we will always service it, and we will always support you, which is something that Testo has stood strong on for the last 60 plus years. So just to talk about the thermal imaging aspect with Testo, as I mentioned again, more than 60 years of experience in measuring technology, measurement solutions for the most demanding target groups and applications. I'm sure many of you, whether you're just getting into thermography or you are, say, a level 1, 2, or 3 thermographer, if you are a facilities manager, I'm sure you understand that some of the environments that you could be in, some of the applications you are using thermal imagers, they are pretty demanding. Whether it's being at a electrical substation where you've got electricity flowing around you, you feel the hair on your arms start kind of perking up a little bit, or you're in some high temperature areas for different metals and smelting. You understand it. It is, we have a lot of solutions that cover everything. From 2007 is when we had launched our first thermal imagers that were developed entirely in Germany. And since 2007, our imagers still are designed, developed, and built, as well as calibrated, factory calibrated in Germany as well too. And there'll be a little bit more about that later. Highly skilled employees for research and development, product management and manufacturing in the Tiedesee headquarters office, which actually this is a thermal image taken of our corporate headquarters in Germany. And as mentioned, these are designed, built, and calibrated in Germany. So just a little brief background. We want to make sure that we're covering every aspect, because with Testo, we obviously support our tools. We also want to educate our client base as well too. That's one unique feature and kind of how we differentiate ourselves from the competition is we like to make sure that we're supporting our customers. You're making the investment in us, and we want to make sure we're making the investment back into you to be able to support you through the use of our tools. But just a little brief overview of how the thermal imager works. All bodies emit infrared radiation, whether it's you have something hot, you have something cold, there's always going to be radiation that is emitted. And with that, you have a specialized lens that's going to take that IR radiation and it's going to focus that into the sensor, which that sensor is then on a board. And then that board will then take that amongst a couple other little things that go on as well, is it will go to the camera display where this information will be in the thermal imager, where you can adjust your scales, you can adjust all the leveling and the spanning that goes on with an imager, as well as if you have a fixed focus or a manual focus or even an autofocus camera, you are able to get a clear picture and be able to see the emittance of that radiation off of a body. And I'm sure we all know a black body is, we all know what that is, and that's kind of the true aspect of making sure from a calibration standpoint from those perspectives. So let's talk about the applications here. What are some of the applications that you're going to be using a thermal imager? There's energy consulting, structural defects, construction quality, leakages, whether it's in a building, whether it's air leakage, it also could be a pipe leakage. There's also ways within buildings of preventing the mold formation, which one of the true aspects of a thermal imager is it does not detect mold. It will give you the evidence that mold could be present within a building. So that's taking into consideration humidity, just having an extra, for example, we have probes that do connect to our thermal imagers that can detect high levels of humidity. And by looking and seeing, you can detect that potentially there could be some mold in this area. So we'll cover that a little bit later. Also checking radiators, making sure they're working efficiently and that there's no blockages within them as well. In the preventative maintenance sector, again, our imagers will cover the electrical components, fuses, connections, and switching cabinets. A primary example of the electrical components. Mechanical components such as bearings, motor shafts, bell housings, bushings, anything that has rotating equipment is another aspect where thermal imagers can be used and where Testo has a strong presence in. High temperature analysis on steel ladles and pipelines. You're able to use that with certain accessories and aspects for the different cameras that we have. And again, we're going to go into the different cameras because each camera has a unique place for the different parts within the application so that you are covering what you need for those specific applications. In production, you've got plastic fiber production, for example. understandings of making sure that the different properties that are going on in that process, glass production, making sure that the glass is being heated to a certain temperature, it's cooling properly, that it's not cooling too fast and cause breakage. And then level monitoring with closed liquid tanks, an application that is used a lot in the thermal imaging world as well. In research and development, believe it or not, a lot of thermal imaging is done in the R&D sector. So analysis of minute electrical equipment, your temperature distribution monitoring. We do have a specialized imager that can actually record video through the process analyst package as well. So if you are doing process analyzing for research and development, there is a specific imager and a specific need that this does accomplish as well in thermal imaging. In power generation and power distribution, overhead power lines and substations, you've got your bus bars, your connectors, making sure that the generating stations and the generators are working as they should. A big part within preventative maintenance is making sure that these connectors, where they're just constantly having electricity flowing through them, not to mention the solar aspect of the sun taking a toll on these different connectors. These are aspects as well that from thermal imaging you are able to cover with imagers from Testo. Also, not to mention solar plants, especially solar panels, this is becoming a big thing now within the United States, is solar farms, solar panels. So being able to inspect a panel and trying to find the bad board or the bad little puck, as what they call it, that will go into a solar panel. Also not shown here is wind farms. So the mechanical turbines and the spinning equipment, also thermal imagers are used in that as well. And then some other applications, veterinary medicine, being able to determine, for horses or animals or any kind of veterinarian usage. This is thermal images is also used as that as well. Human medicine can be used. Archaeology, actually, believe it or not, this can help. Thermal imaging does help in that sector as well, and even in the automotive sector as well, especially with mechanics, trying to find different aspects within the motors. As you can see, there's an example of brake pads, just making sure in the brake rotor on how they are used as well. These are other applications that thermal can be used in. So just to kind of give a overview of what the portfolio of the Testo thermal imagers are. So we've got 6 different imagers here. And I know there's other options of many other imagers that are out there, but these specific 6 are unique to each application that they're relevant in. Whether it's the lens size, whether it's the pixel resolution, whether it's the temperature range that the imager is calibrated for that it will work in, the optics set, even the detector that is in these imagers as well too. Every imager does have a unique spot where they fit, and also the different applications that they're used in. So what we'll do is we're going to go in, we're going to look at the imagers, and then we're going to talk about the great features that these imagers have, and just how Testo is unique and how we are transforming thermal imaging from our technology and the way that we go about it with imagers. So you can see here we have our 865S, 868S, 871S, and the 872S. Again, these are for the doers, more of your, I'd say, kind of your facility managers, your energy consultants, a smaller imager that's compact and robust that has a lot of great features. And then you've got your 883, which is the imager for your industrial sectors, your power distribution folks, your solar groups, and also even a imager where in the electrical components, this also has some unique features and some unique different pieces of software that work as well. And then the Testo 890 is our top end imager that has the process analyst functions, and it's able to do some data logging as well too for R&D purposes. So first looking at the Testo 865S, just to cover the resolution, this is a 160 by 120 pixels with Testo Super Resolution, which gives you a crisper picture, and we will talk about more how the Super Resolution works. The thermal sensitivity is 100 millikelvin, so you're looking at a range of -4 to 536 degrees Fahrenheit with a fixed focus. Really, this one for this imager, this fits into your structural defects, ensuring construction quality, energy consulting, and also your leakage detection. The unique one of this is it will automatically detect hot and cold spots, and always the right measurement distance with the IFOV warner, which actually is a unique feature that gives you a 3x3 pixel square within the center of the imager. As you can see, the little round piece within the imager on this screen, with the IFOV warner on there, you're actually able to get a more accurate depiction of what that temperature is because of the way that the pixel size is captured. So as opposed to taking things from outside, because it may not have as many pixels outside that little square, you're actually able to get a more focused reading on what that temperature is to be able to determine the differences. So for example, if it could be a 10-degree difference with the IFOV warner on, that 10 degrees could make a big difference in making sure that that component is getting closer. For example, like an electrical cabinet, say that the connection is loose and it might be taking something off that's colder behind it as opposed to what is you're looking at. You might actually misdiagnose something, or at least call out that, hey, there could be a potential issue here. There needs to be some action taken. So that is one part of the IFOV warner, is one feature that Testo does have. And by giving you those additional pixels, makes it a lot more of an accurate measurement. So the Testo 868S, again, the same resolution, same super resolution. We do have a higher temperature range and a better thermal sensitivity with it. Again, this is a fixed focus camera. The one part that this one works in, this works in leakage detection, so more of the energy consulting building side of things, indoor specifically. This one has the integrated digital camera, so when you are taking images with our Testo thermal imagers, the 868S is able to get a thermal image as well as the actual real image, so that when you're doing the post-processing, you can actually see what you took a picture of, the location, and be able to have that both within the Testo IRSoft software, which we will cover later. The other aspect of this is the Testo Thermography app. You can use that as a second display and for efficient documentation. So if you need to make any kind of quick notes or a quick report for just a quick spot, the Testo Thermography app, which is free, and we'll cover that here shortly, you are able to get reports quickly and effectively through the app. So for the 871, we are going to bump up in resolution to 240 by 180 with super resolution enabled. This is 480 by 360. We've got the thermal sensitivity around the same range. This is a fixed focus. With this one, the difference of this model is this one also works in the building sector, leakage detection, preventative maintenance. That is one aspect that this imager will work. This also has the Testo Thermography app, and it also has a wireless transmission of readings from our Testo 770-3 electrical clamp meter. So if you're doing any kind of work with an electrical cabinet, you can have the clamp meter connected onto a line. You can get the amperage reading that is going off of that line, and it will actually transmit that reading to the screen of the 771S right onto the top of that when you have that connected. Also, the 605i thermal hygrometer. This is used for humidity readings. So if you have this switched on to humidity mode or the humidity mode measurement program, that will actually transmit the relative humidity of that area while you're getting a thermal image, so that you can determine if, okay, there's some extra humidity in this room, there's a potential for mold. Obviously, if you switch to humidity mode, it is going to change your palette color, and it will give you more of that green, yellow, red to kind of understand that, hey, there is a potential for mold. Not detecting mold, saying you actually have mold, but it is just giving you a risk-based analysis that there is a higher potential of mold. So a common thing within thermal that I have seen is people have asked, well, does this detect mold? No, it does not detect mold, but it will give you a risk analysis of stating the area has a high potential for mold based on the different criteria you're looking at. Now for the Testo 872, the resolution is bumped up even further to 320 by 240. And again, with super resolution, we're going 640 by 480. Your thermal sensitivity is at 50 millikelvin, and your measuring range is -22 to 1202 degrees. Again, a fixed focus camera, a different lens, a 42 by 30 lens. This one, again, will utilize the wireless transmissions of readings from the 770-3 and the 605i. This also does have a built-in laser marker as well. And the Thermography app can be used as a second screen. This one, again, is more of the higher end camera within Testo that is for the structural defects for building, energy consulting as well, leakage detection, and also preventative maintenance, given the fact that it can use the 770-3. So having the clamp meter and the imager working at the same time, you're getting accurate readings and you're getting all your information so that when it comes time to doing that report, you're able to put together all that information and make sure that you give it to the customer or the facility that you're working for, and that they can make their proper arrangements to have an electrician come in or someone come in that can actually certified to do that work. Because as we know as thermographers, we generally just give you, hey, look, here's some potential issues we found, here's the report, happy to come back out when that person comes, they make the fixes, and then we go in and do that. So again, having the certified professionals is important when doing our jobs. So for the Testo 883, this one is, again, a 320 by 240 with super resolution. This one was released about a year and a half to almost 2 years ago now that this imager has been out. This one primarily is a imager that can do everything from building, facilities, and leakage, and preventative maintenance. Also can do power generation and power distribution. So a great imager inside the four walls of a transmission station or anywhere where there's power distribution, you're able to cover a lot of different applications within a location. Some of the special features they have is Testo's site recognition, which we will get to in a little bit here. Testo's site recognition is automatic recognition and storage of measuring locations. Actually a pretty unique feature when it comes to planning out your inspection routes and using barcodes to have if you're constantly doing inspections. The scale assist is the automatic contrast adjustment for the optimal evaluation of a building shell, more on the building side of things, but this gives you an idea of the different scales that are used. The Testo IR Soft, again, this is the software which we'll cover. And again, this also has the wireless transmission of readings from the 770-3 clamp meter as well as the 605i thermohygrometer. This camera is a manual focus camera. You can get this in a kit, which does have a standard 30 by 23 lens. Also, it can come with a telephoto lens for greater distances, a 12 by 9. There is an annotation feature as well that it does come with an earpiece that you can speak into the imager where it's saved when you're taking those readings, and you're able to get everything that you need when it comes to taking your notes on the actual inspection that you're on. Last but not least, the Testo 890. This is one where the resolution is 640 by 480. With super resolution, we're at the 1280 by 960 and the thermal sensitivity of 40 millikelvin. This can go up to 1202 degrees as well as an optional up to 2192 degrees Fahrenheit. This comes with a, you could get it with a optional high temperature measurement lens and filter. you're able to do some of those higher end applications where, again, where you have smelting, you've got high temperatures that exceed the range. So this is also can be done with this imager. Again, the manual focus and also autofocus as well comes. You can get multiple lenses because there's multiple configurations. So if you're interested in purchasing this camera for, again, research development, preventative maintenance, power generation, power distribution, you're able to, with this camera, be able to do a lot of things with what you need. This camera is very powerful. It also does have a panoramic image assist where you can take multiple pictures, piece it together for one big image. So you can break down smaller areas or have the whole image as a whole. The process and analysis package is the video measurement and time lapse. So we do have a data logging feature with the 890. So for those that are doing some research and development of a process and you want to try to capture everything that is going on, this camera can do it. Again, 4 lenses to choose from. You've got standard, you have a couple standard lenses, telephoto lenses, and a super telephoto lens. And then again, you do have the high temperature measurement, which can go up to 2192 degrees Fahrenheit. So just to give you just a little overview of the technical features, because I figured talking the technical speak now before we get into some of the unique features, I think will help kind of set the stage of how these are all unique cameras and, again, how Testo is set apart for when we are transforming thermal and what we bring to the table that is unique. Again, you can see what's fixed focus, manual focus, autofocus, the different lenses, what external measurement parameters there are, as well as which ones work with our app, which also has the different features such as Testo site recognition, and as well as some of the other features that we're going to cover here very shortly. So going into the features now, one of the helpful features we're going to hit at is Testo Super Resolution, which every imager from Testo has the ability of Testo Super Resolution. Again, due to the low resolution of thermal imagers to the technology used, small and distant objects cannot be measured at all or can only be measured incorrectly. So how we've looked at this is previous solutions have had larger detectors, which are going to raise the prices of imagers. Obviously, we understand cost is a big aspect when it comes to bringing in a thermal imager because it is a big investment. We also want to be able to reduce the measuring distance, which is not always possible. So sometimes you have to be far away to be able to be safe is the biggest aspect there. So making sure that we have the ability to do that. Telephoto lens, they're only useful for distant objects. So with super resolution, this uses the natural movements of the hand when taking thermographic images and creates a sequence of minimally offset images. So the real measured values are recorded with a crisper image. And the one thing within thermal is we want to make sure that we have a very crisp image as well as having the right scale set that we are getting everything we need so that we can do a general analysis of what we are inspecting. And with that inspection, we want to make sure that we're reporting it and that we are presenting that to the customers. We have a potential anomaly here with this image that we are looking at or with this specific component. So this is an algorithm that is used that takes additional information to generate a higher resolution thermal image with 4 times more real measured values and a geometric resolution improved by a factor of 1.6. So super resolution, again, this is something you can enable and disable on the instruments. You are able to do this live or with the software as well. So everything is taken and it is given to you in a full image on the screen. And then also when it comes to the IR soft, you are able to download this and do your post-processing within the IR soft as well. The Testo Scale Assist, this is the optimized contrast at all times. Again, this is going to depend on the indoors and outdoor temperature. The thermal image of the same object can look different. And as you can see, we have 2 examples if the scale is set too low or if it's too high. And the one aspect which thermal imagers generally work off of is the rule of 10 to 15 to 18 degrees is that difference. That is where you're able to detect. So ensuring that you have your indoor temperature set and that is a known value, what your outdoor ambient is set at. You also want to determine how much solar loading has that structure. If we're talking buildings, how much solar loading has that had during the day? So generally when you're doing a thermal image or when you're doing a thermal inspection of a building, you're generally doing that at specific times when the sun is down and right at dusk. Or if you don't mind getting up early before the sun comes up and before solar loading can take place, are you doing it in the morning as well too? But again, the solution, after entering the indoor and outdoor temperature, the Testo scale assist automatically adjusts the scale to the optimum setting. And this is two advantages: objectively comparable images and optimum contrast. And then any element that are in the way or unimportant are automatically faded out. Again, such as a background, we understand you're not going to take that background into play. You're going to be obviously looking what is in front of you. And misinterpretations are prevented, and constructional defects are only displayed if they really exist. So depending on the indoor and outdoor temperature, the color distribution of the thermal image is automatically adjusted during the measurement. And as you can see, the image on the bottom is a correct set scale, and you can see where there are issues within this structure and where they're at. Or even if it is good, there is aspects as well to making sure that everything is good as well. Perfect example, I was involved in building a house and actually got to do a thermal inspection on that house, and it was actually pretty neat to kind of see, hey, did they build it correctly? Did they do the windows right? Do I see little holes here and there? So that was some of the training that I got to do, obviously going through my level 1 and being able to use a thermal imager. That was something that was actually pretty neat to see, and kind of how these different tools work and how these imagers work with the different lenses and scale sets and so on and so forth. Connectivity. We did briefly talk about two instruments that Testo does sell. We are able to integrate more measurement parameters into the actual thermal image. So for example, the 770-3, the Bluetooth clamp meter, you are actually able to do electrical components. So if you're able to get readings off those components, it will actually have, you can turn that on to the Bluetooth setting, turn the imager's Bluetooth setting on as well too, have that data feeding to you constantly so that when you are taking images, you're able to get this all in one shot, so that when you are doing your post-processing, you have an amperage read, you've got your thermal image to show you if there's any hot spots or any spots that are in question or suspect. And that is one aspect with the imagers, especially the 871, 872, and 883. Also for the 605i, again, this is for the humidity within a space for buildings, being able to determine what is the humidity range within that space. And again, it will also switch on the humidity mode. This will give you the green, yellow, red palette. And again, this is not going to detect actual mold. This is going to give you a risk analysis or a risk factor of low, medium, high. There is potential, this has a high risk or a high potential for mold to be present. So I just want to make that clear, is that is generally how we're telling for mold. This is all transmitted via Bluetooth. So again, this goes right to the imager. So all the readings are being captured there. Fast detection of damp spots and the risk of mold in buildings, or the load status of a switch cabinet. Again, here's an example of the humidity image and the humidity feature within the one of the imagers, the Testo 872S. The challenge, again, surface temperature and air humidity in the room play an important role in the assessment of whether or not a thermal abnormality is suspect to mold. And again, the solution, the thermal imagers depict the distribution of the moisture. You can see the areas that are prone to mold on the display itself. Obviously the red, green, and yellow. You can get an idea of, okay, we're at 50% relative humidity at, I know this is 20 degrees Celsius, but this is around 68, 72 in that range. This has an acute mold risk of that red area where it's at. So potentially there could be some water leaking in, there could be a pipe that could have burst, and that is just constantly saturating the area. So a thermal imager will be able to help you support that, hey, look, this is the area we might need to take a look at. This is where you want a certified building professional to come in to support whether this your inspection is true or not. So the next feature that is on the Testo 883 is the Testo site recognition. This is a very unique program that came out with the 883. This was developed to support electrical components, kind of small scale or more of your inspection path with the Testo 883. So this is an automatic archival and assignment of thermal images to the measuring object. So we're going to hit the challenge here. Where you have similar measurement objects, allocating and managing thermal images that look the same is a very complex process. And I'm sure some of you there are shaking your heads. Yes, I'm looking at a lot of different electrical components a day, or I'm looking at different components, bell housings, or different motors a day. And sometimes when I go back and I'm doing the post-processing, I can't exactly remember which one this was. Was this engine 1, 2, or was this cabinet 5, 6, 20, 2A/1? This is a common problem, especially in the maintenance field and the maintenance sector. So those that are doing constant inspections within their own facilities, or you even have a contract with someone that is going through and doing these inspections in a facility, Testo site recognition is a fantastic tool that allows you to organize everything. So what we're going to do here is we'll go kind of around the circle on how this starts. So with an 883, if we're going to start, and I'll try to bring my mouse into here as well. So what you're going to want to be able to do is you're going to create an archive structure in the Testo IRSoft software. So what you're going to be able to do is if you know the inspection path ahead of time that you're going to do, or you've been doing this for some time, or even if you're new to a place, you might want to go before and set your path. So what you can do is measure out what are the different aspects that I'm going to be looking at. So for example, we'll do a switch cabinet, and I'm just going to kind of come up with a couple different ways that we can go about this. So we got one cabinet, we might have 3 cabinets we got to take a look at. We've got maybe 10 or different switches within there we've got to look at. So within that, what I might have to do is to set up my archive within my Testo IRSoft, is setting up the measurement site and then the different parts within that site. So I could have cabinet 1, and I'm going to set my substructures to switch 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do this with IRSoft, or you can import this in if you have an inventory list already ahead of time. Once you set this, you're going to transfer that archive, whether it's in IRSoft, which is where it's going to need to originate, and send that down to the camera. And then what's going to happen is it's going to give you identity markers or QR codes, 2D data matrices, any kind of barcode. Those, what you're going to be able to do is take those barcodes and be able to set them to the assets that you're going to be taking a look at. If it's too small or too complex, I've always recommended to some users that can't necessarily fix these markers, which they could come down, they could blur out over time. You can actually create a book and make sure you use the camera to scan that. So anytime you are going into a different camera or a different cabinet or a different component, and if you need to take multiple images, so if you want to use, say, we're always starting out with grayscale, we always want to make sure we're starting out with black and white or grayscale. And then if you want to switch it to color eventually, once you have that, you might be taking 3 or 4 different images of one piece. So with the site recognition, you can actually set what the actual scale is, your emissivity. You can also set, for example, what is your palette you want to use. And if you want to take more, you can always switch that later. But ideally, you can preset everything you're going to do so that you can walk up to that asset, scan the barcode with site recognition on, and once you scan that, it's going to automatically configure the camera, and you're going to be able to capture your images of those specific components of what's going on there. So you're saving time, you're saving effort. You don't have to go back through your notes and, okay, well, this had this emissivity of this, I had this palette, I've also had this scale range set, so my range was set to these to where these are at. This will all be done for you with the site recognition feature. Once you're done capturing the images, you transfer it all back to IRSoft, and then it will download everything into IRSoft, and then you can be able to go through your whole processing along with the real image, do your post-processing with IRSoft, and have it all in order so that you know your inspection path where you're going in. So the images are automatically assigned correctly to the hierarchy you set up ahead of time. So that again, you're not going back and forth and moving pictures around and, oh, I did this, I did that, I went this way, I went that way. No matter when you click that image or wherever you click that barcode, all those details will change to that and will save it within that folder structure. And then you also have the ability to export the work results to third-party programs as well. Or again, Testo has their own software, which I understand that is a big thing within the thermal industry, is actually having good software that you can do post-processing and creating your reports. And again, we're going to cover that software here very shortly. So here is the Testo Thermography app. Again, this app is a free download. I know everybody loves free. This is a free download for iOS and Android. You can actually download the app now if you want it. If you have an imager, you can go ahead and connect it up with the ones that are compatible, which is the 868S, 871S, 872S, and the 883. You can live stream and operate a thermal imager and use a mobile device as a second display at a time. So you actually can set the imager, for example, on a stand, or someone else can be using it, and you can be kind of walking them through to be able to use it as a remote control. You can control the imagery using your smartphone or tablet. Your analysis, you can insert measuring points, establish temperature profiles via curve, add comments. So you can do some quick processing with that as well. So if you have someone that is going to take the images, you can kind of guide it with the app, and you can also kind of do a lot of things on the fly as well too. Documentation, again, you can select images, store relevant data, see a preview, and send a report to your customer or your supervisor. The one cool feature, which is nice, I actually did this with my son. I let him walk around with an imager and actually was telling him where to go. It was actually kind of funny that you can see this happening live, and he's sitting there taking pictures, or you can do all sorts of things. So if your boss wants to see what you're doing, or say your apprentice is out there doing it, you can definitely watch what they're doing, and you can also use it as a good learning tool to teach as well too on kind of how to do things. So that is nice with the Thermography app that you can have a little fun with as well. So for the Testo IRSoft, again, this is, I think, one of the big important differentiators with a lot of the other competitors out there. I was actually at a thermal conference this past January, and a lot of users that were coming up and were asking about what is unique with Testo. And my question to them was, well, what is something you don't like about with the current imager you're using? Well, first things first is the analysis software. I know there is third-party software out there. We're very well aware of it. The one thing that a lot of other imager competitors have is not such great software. My question was always, okay, what does it come out in? Well, this comes out in actually a post-processing engine that you can use. So we can process and analyze thermal imagers on the PC professionally. As you can see, here's an example here for the IRSoft software. And again, this is actual free software that if you purchase a thermal imager, this software is free to use. This will do correct emissivities of different materials for image areas or individual pixels. You can highlight the exceeding or undershooting of limit values or pixels in a certain temperature range. You can identify your hot spots, cold spots. You can also add the comments. You've got histograms. You've got all the different things within that image. You can also actually affix the thermal image, which you can see here, these pipes on the ground. You can actually affix the thermal image on top of the real image to see exactly what is going on here and where the location of this is. The nice feature is you can take all these images. There are canned reports on there, or you can create your own report based on what is necessary for what you need. And again, the analysis software, Testo IRSoft, is included with every Testo thermal imager. It is free of charge and does not require a license, which is a nice feature to have Granted, that software is a very important piece because the most time-consuming aspect of an actual inspection with thermal imagers is doing the post-processing and creating that report. So with Testo and our Aerosoft software, you are actually able to get your job done quicker and more efficient with actually using the software, and as you're processing that software, create the report at the same time. So a very unique feature when it comes to Testo and how we are also transforming thermal. Again, the panoramic image assist, this displays large objects on an image in accurate detail. You can kind of see how it works, how it's put together. You sometimes can't get that full detail. So the 890 actually has this feature, which the panoramic image assistant from Testo combines up to 3x3 individual images into one high resolution overall, which can be analyzed and documented efficiently. So being able to kind of get the whole picture with little pictures put together. Process analyst package, again, this is with the 870. Pretty straightforward that you are able to, in a thermal process, static single images are not meaningful. We understand the term nuking. So when the thermal imager is nuking, this will actually go and log this process as you're going. So you can store the subsequent or sequences in the camera itself at selectable intervals, like a time lapse, and carry out a live measurement on the PC at up to 25 hertz. So again, this feature is with the 890. This one actually, and even the 885, which if you have the 885, it works for that as well. This process analyst package does that trick for R&D purposes. Now, the last part, because we're getting close to the end here, is another aspect that makes Testo very unique. And I know we talked about how they're designed and built in Germany, but we also want to take into consideration, especially when you look at an imager, a lot of the ranges, a lot of the accuracies, a lot of the thermal sensitivities, they're all very much the same. Again, the detectors, the lenses, the way that they're put together and built, the different software and aspect that are in them, almost every imager looks to be the same when it comes to on paper. But the one thing with Testo is we also take into account what are the measurement conditions. So you're doing work outside, are you inside? We understand that each region is very different. It's cold, it's hot. There's always changing ambient conditions. Or if you're doing transformer stations in the desert, it is a hot ambient environment. You need to know the uncertainty for your interpretation, and you need to be able, and now you need to know what the desired thermal imager is to be able to provide and have a look at the technical data. So we want to take a look at that technical data. But the biggest thing is you also want to take into account what is the operating range for that imager. Is it going to be able to stay the same whether it is -15 or if it's plus 50 degrees Celsius, which is about, just trying to think, about 150 so degrees. Sorry, my translations of Celsius are a little off here. But the point is, you've got different ambient conditions. And you want to make sure that no matter what, because we understand sometimes when a car starts in the wintertime, it doesn't start as good and it's not going to start as fast from how older cars used to start. So you want to make sure your imager, no matter what, is working in -15 or plus 50 degrees Celsius, whatever that range that the manufacturer specifies. So no matter if you're outside freezing or sweating, there's no influence of the ambient temperature condition on the accurate reading of the scenery you're taking a look at. And this is all because of our complex calibration during the manufacturing of our imagers that we as Testo provide with our imagers. So the Testo adjustment is roughly divided into the raw image, the correction value applied to the raw image, and the temperature per pixel is determined from the characteristics curve. My apologies here, this is in German, but this is to give you an example of exactly how this is calibrated. We're generally taking 3 to 5 points of calibration when we're going through the factory calibration, and that we're actually taking imagers and putting them into an environmental chamber. I've been to HQ, I've seen these chambers on where they do these things, and it is truly a wonderful exercise and also shows you the level of detail that Testo takes into their imagers. So as opposed to being in a 72 to 68 degree ambient space, these environmental chambers are creating different various ambient temperatures so that the characteristics of each pixel are realized. And the ambient correction values are calculated so that if it is 0 degrees or if it's 100 degrees within a 24-hour span, that no matter what, that Testo thermal imager is going to work at its specs for its operating range and also its range for the temperatures and accuracies that we are stating. To achieve a full detector size measurement, a parabola per each pixel is considered, as you can see here in the right-hand graph. The performance of each pixel in relation to the ambient temperature is known. And after this, we were able to control sensor sensitivity by applying a control voltage to that board and just making sure that we are getting that accurate image and we're getting those accurate readings that we need. Then a final calibration step using different scene temperatures leads to a full detector size measurement accuracy. So this from Testo, when it comes to actually doing a factory calibration, is understanding, hey, we go the extra mile to make sure that this is going to work in any ambient conditions because these imagers are exposed to very different temperatures at a different time. So in wrapping up this webinar here, and your advantages with Testo and how Testo is pushing the envelope when it comes to thermal and how we're transforming this craft. So a comprehensive portfolio of thermal imagers for all requirements. Our Testo imagers have specific homes and ranges for what you may need based on your application. The brand quality, which is made and calibrated in Germany, again, made, designed, built, assembled, and serviced in Germany, as well as the local subsidiaries as well. The assistance functions help you obtain optimal thermographic images. Smart networking with your PC and smartphone tablet for efficient and impressive documentation of your work. Again, we understand that the biggest thing with thermal imaging is the software. That is some of the biggest pains that a lot of thermographers come across. There are third-party software out there. There is third-party software available, but manufacturers should also have really good software as well too. And Testo provides you great software that gives you that post-processing, is efficient, can be done, and creates the report at the same time so that you can get back to your next job or spend that additional time with your family for when you do have jobs that you need to get done. Support for your measuring tasks via downloads, guides, and seminars. That is one aspect as well. And then also having local service centers for advice, support relating to aspects of thermography. Again, if you have, especially if you're in the US and Canada, you have issues with your thermal imager, we have a support staff. We have experts on staff that can support. We even have the backing of HQ as well when it comes to any kind of work that needs to be done with a thermal imager as well. And with that, I believe we are at the end. So Doug, I will turn it back over to you.
Thanks very much, Aaron. That was very, very thorough. And I think we have one question here. All right, I'm sorry, that was more of a comment, but we do have another question here. I believe you may have mentioned it, but what is the best palette to use when starting out a thermal inspection?
Great question. Yes. So the best palette to use, and I can thank my boss for it because he's a level 3 thermographer, is you want to use the grayscale. And the reason with the grayscale is you're able to get that differentiation of where you're looking at the specific component or inspection. So having that in the grayscale will give you those differences that you can realize much better. And then also, if you want to switch in the color, you can do that, but you always want to have a grayscale.
All right, that's fantastic. And we are running out of time for today. And let's see here. Just as a reminder, today's webinar is just a part of our 2023 webinar series. If you are looking for more detailed information on our products and services, please join us for one of our upcoming live webinars. Links to upcoming webinars will be included to the follow-up email after today's presentation. And once again, on behalf of Testo, thanks for everybody who attended our session today. And thank you, Aaron, for such a great session on transforming thermography and using Testo thermal imagers. Once again, thanks, everybody. Have a
Thank you,
great day.
everyone. Thank you.